In this video, I want to talk about the rational root theorem, which is the theorem that helps you if you feel like you don't have enough information. This helps you figure out some more information. It's kind of a pain in the tail, but we're going to do it anyway. All right. So if I'm looking at this and I want to find the zeros of p of x, in order to find zeros, all right, we need factors. Factors lead to zeros. Factors lead to zeros. So I have to write p of x in its factored form. Well, if I'm looking at this, the only thing I might try is grouping, but I don't even have two equal groups. There's nothing, there's no GCF in these. Like, there's not a lot I can do with this, okay? So I can't factor by grouping. I can't use U substitution. I don't have any binomial to try dividing out to make it smaller. So there's not a lot I can do right now. So that seems sad, but we are not ones to quit. We are going to persevere. We're going forward, and we're going to use the rational root theorem. Okay, this is what it says. It's going to look like a lot of nonsense, but we're going to do it out, and then you'll see that it is slightly less nonsense. All right, so if I have a polynomial that has rational roots, then we say they're in the form p divided by q, where p is some factor of the constant term and q is a factor of the leading coefficient. All right, so you're always remembering constant term over leading coefficient. What does that mean? All right, well, in this problem, if I want to find the roots of this problem that I was given, I need to figure out what are the factors of the constant term, which is p. So in this case, that constant term is 6. So the factors of 6 are 1 and 6, right? And 2 and 3. So we could list the factors of 6 as 1, 2, 3, and 6. But we also have to remember that 1 can be both positive and negative. 2 can be both positive and negative. 3 can be both positive and negative. This is turning into a mess. I'm going to write it a little bit neater. So my factors of 6 are now positive and negative 1, positive and negative 2, positive and negative 3, positive and negative 6. Okay, so I actually have 8 factors of 6 that I need to consider. We also want to look at the factors of the leading coefficient, q. Well, the leading coefficient, first off, we have to make sure we know what it is. In this case, it's 1, right? If there's nothing in front of that x to the 4th, you write a 1. The factors of 1 are just plus or minus 1. That's it. That's nice and easy. So now, what we're going to do is we're going to list out all the possible rational roots. This is going to look like a mess, all right? And the possible rational roots are all the factors of p divided by all the factors of q. So I'm going to say on top are all the factors of p, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And on the bottom are all the factors of q, which are just plus or minus 1. And what this lets me do is this lets me make a list of possible factors that I could try out. Okay, and what I'm doing is I'm saying, well, the first thing I could try out are positive 1 divided by positive 1, negative 1 divided by positive 1, all the division problems that are in here. Negative 1 divided by negative 1 and positive 1 divided by negative 1. I don't know if I listed them all, but you've got it, right? So if I'm saying 1 divided by 1, all my options are plus or minus 1. Okay, similarly, 2 divided by 1 is plus or minus 2. I can't write it that way. All right, plus or minus 2. I have plus or minus 3. What is happening? Plus or minus 3 and plus or minus 6. okay? I have a list of 8 options here. Now 8 is a lot of options, but it is way less than infinity options, because what's going to happen next is I have to guess and check all these options until I get something that works. All right, so I would have to guess and check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until I got something that works, but I know that most of those are not even possible. The only possible routes are those in this box. So instead of checking infinity options, I only have to check 8, and that's better. So what we're going to do is we're going to use synthetic substitution to check our options. The first route I'm going to try is 1. So come over here, and I'm going to do this small because I may or may not have to do this more than once. I'm going to test 1. My coefficients of p of x up here are 1, -1, 1, -3, and -6. Okay, so here I go. I'm going to do this out. Bring the 1 down. 1 times 1 is 1. Add those, it's 0. 1 times 0 is 0. 1 plus 0 is 1. 1 times 1 is 1. -3 plus 1 is -2. 1 times the -2 is -2. And that is not a remainder of 0. So 1 is not a 0. No bueno. Let's try again. Let's try -1. Same coefficients. 1, -1, 1, -3, -6. Okay, and I am going to bring down the 1. -1 times 1 is -1. -1 plus -1 is -2. It's 2. 1 plus 2 is 3. This is -3. It's -6. -1 times -6 is +6. Hey, that equals 0. So this is very exciting because when I have a remainder of 0, I know that that has to be a 0. Okay, -1 is a 0 of p of x. So now what I'm going to do is I'm going to finish up this problem. Once I know 1 0, then that makes it so much easier to find the rest of the zeros. So I'm going to go onto a blank page here, and I'm going to say that because -1 is a 0, I know that x minus 1 has to be a factor. Okay, and then let's use these numbers down here to be the coefficients of my quotient. I started with an x to the 4th, right? So I know that my quotient will be an x cubed. So I have 1x cubed. I'm going to keep flipping back and forth here because I don't remember. -2x squared. All right. 3x minus 6. So plus 3x minus 6. And these are the factors of, would we name this p of x? These are the factors of p of x. Okay. Well, this first x minus 1 is handy because I know that the 0 of that is 1. But this second one is not broken down very much. But we're going to cross our fingers. We are going to hope that this now factors by grouping. So I'm going to squiggle here, squiggle there. I'm going to pull out a GCF, x squared. What's left is x minus 2. I'm going to pull out this GCF of 3. And what's left is x minus 2. Hey, it does factor by grouping. So my common factor is x minus 2. My leftovers factor is x squared plus 3. I know that p of x in factored form is now x minus 1 times x minus 2 times x squared plus 3. If those are the factors, then I can find the zeros by setting each one of these factors equal to 0. So I know that the first factor is 1. The first factor, when it equals 0, is solved by 1. Holy moly. One more time. When I set the first factor equal to 0, the value that solves it is 1. When I set the second factor equal to 0, the value that solves it is 2. when I set the third factor equal to 0, let's do that over here on the side real quick because it's a little more complicated. X squared plus 3 equals 0. Well, x squared equals negative 3. So x is going to equal plus or minus the square root of a negative 3, which is pretty gross, but we can make it a little bit better by saying, well, this is an imaginary number. So it's plus or minus I root 3. Okay, so our third and fourth solutions are plus or minus I root 3. And these are the values of x that solve that polynomial. All right, these are the zeros of x. There are 2 that are real and there are 2 that are imaginary.